Alright then, let's kick off the demo of lenses on AWS with MSK. So what this is lenses 4.0. It's deployed on AWS. We have the brokers here. There's 3 brokers in the cluster. We can see that this is the URL of the brokers from MSK. Also Zookeeper as well. We are collecting the metrics from Zookeeper and the Kafka brokers using the open monitoring solution that MSK has. We also have a schema registry deployed. We deployed that ourselves. And we also have a Kafka Connect cluster because we want to demonstrate later on writing data out to S3 and Elasticsearch. So I just go back to the dashboard. We'll get an overview of the live data coming through here. Again, this is a test environment, it's a demo environment, so there's not a lot of data in it. Just over 2 gigs, but we get some high-level information of the overall throughput of data across the platform. We have 12 topics that are being created, and for these 12 topics we have 91 partitions, and we have some monitoring here on whether the partitions are offline or under-replicated. This will go red and there would be an alert sent out if there's a problem. We have 4 schemas in the schema registry, which are attached to the topics. We have 26 data policies. I'll show them later, and we also have here an overview of the applications that are running, and there's none running at the moment. We will deploy them shortly. What we have here is also the auditing, right? So everything you're doing via lenses is audited. So you're coming into lenses, we're authenticating you, but we're also auditing every user action you do as well. And these are some of the alerts that have been fired based on some of the alerting rules. So first up, I just want to go down sort of like a platform engineer route. So what we have here is how you control the user groups and the management of lenses, plus all the admin aspects such as the alerting and creation of connections, etc. So when you log into lenses, you can log in with basic auth. You can log in with LDAP, you can log in with Active Directory, you can log in with single sign-on. So we have a number of single sign-on providers. And once you're logged in, then you're logged into a group. I'm actually logged in as an admin here, but we do have groups defined. So in this case, we have one group, AWS Demo. And you can do all this from the command line if you want to, because we have APIs. We have a command line tool as well. So you can automate everything. But what we have here is a group. And this group has data namespaces in it. So this is actually allowing multi-tenancy on top of Kafka. So what we have in this group is whoever belongs to this group, they can see 2 data namespaces. In one, Kafka, so that's using the Kafka connection, because we can also support multiple connections. So on the Kafka connection, we allow everyone in this group to be able to see any topic that begins with AWS Demo. And in that namespace of topics, they have this set of permissions. They have create topic request. We've actually said we don't want them to create topics explicitly. We want to put data stewardship around it so we can actually manage the creation of topics. We also have delete the topic in there if they want to, configure topic, view data, etc. So it allows a fine-grained control in a subset of topics on top of Kafka. However, for the same Kafka connection, we also have another namespace policy. So this is actually saying that in any topic that begins with production, the only thing people in this group can do is view data as well. We also have a set of application permissions that are scoped onto the data namespaces that you can view connectors, for example. You can view the consumers, you might be able to manage them, for example. Because, for example, if you can't see a topic, if it doesn't exist to you because you don't have a namespace, you shouldn't be able to see the consumers or create connectors, etc. We also can set up permissions over here on the right hand side for anything else such as data policies and the audit alertings. These are things that sit slightly above Kafka and in some case features of lenses themselves. So here we have the user, create the user for myself earlier. So this is basic authentication. We also have service accounts, so you can create a one-time token. For example, let's say Andrew, and we want to assign that to that user Andrew, and in the group AWS demo and create the service account, one-time service account. I could then put that into my CI/CD system, and I could use it with the Lenses CLI to be able to automate everything around Lenses. We also have rules here, so these are infrastructure rules. So in this case, when the broker goes down, we're sending it to an AWS channel. So we have this channel set up. So if we just look at this channel is actually an AWS CloudWatch. So we can route all the alerting that Lenses generates from infrastructure or even data produced that we'll see in a minute, or consumers actually from Lenses. We can route them all to AWS. We have other alerting rules set up here. This is on producing of data. So for example, we expect in this topic, CC payments, to have more than 2 messages pushed in the last second. And again, here you can see we're routing it out to this channel. We could add more channels in if we wanted to. We also have consumer alerts. On consumer lag on top of Kafka, we don't have any set up here. But for example, we could say if the consumer lag is on this AWS consumer group for this topic, let's say CC data is greater than 2000, then also send that off to CloudWatch. So these are some of the events that have been fired and sent off before. These are the channels that we saw before. We also support different types of channels. Maybe you're using Datadog or Slack, PagerDuty, for example, Prometheus Alert Manager. We can also support sending alerts out to that. We also have connection management. Connections are treated as a first-class citizen inside of Lenses, because actually, if you think about your data platform in MSK and something around the data intensity you want to build, Kafka is just one part of it. Maybe you want to write data out to Elasticsearch. Maybe you want to write data out to a Postgres database. So we're actually starting to manage all those connections in a centralized place here. So in this case, we have a connection to Elasticsearch. So we can actually query Elasticsearch, which we'll get onto in the demo. And this is the connection to AWS to handle the sending the alerts to Alert Manager. We can create more alert connections if we want to. Again, this is all configurable via the APIs. Every button I'm pressing has an associated API with it as well. So if we also look at the auditing aspect, so this is very important when you're at an enterprise level. You want to make sure that you're adding compliance to everything that you're doing. It's great that we have all this technology, and opening up data to the wider audience, but we also need to have some control over it. So what we have here is a topic request. Remember on the previous group, in this group, they were only allowed to create topic requests. They weren't actually allowed to create the topics. So it's gone into an approval system inside of Lenses where a data steward can come along and have a look at what's going on here. So I'm allowed to do it. I'm logged in as admin. Okay, great. I requested this earlier. I gave some information about the expected message size, number of expected messages a day, number of consumers, etc., and then information about how I want the topic to actually be configured and a description. So I'm going to say, okay, that's fine, and I'm going to approve that. And now Lenses will go off in the background and actually create that topic for me. What we have here is actually the audit logs. So this is everything that's happened. Look, for example, here we just created the topic that I just approved as well. We can also send this auditing information out to different places. For the moment, we support sending it out to Splunk. You would have to create a Splunk channel and a connection, or you could send it out to a generic webhook. So in that way, that every action that you're doing can be sent off to a system that you already use for your auditing and compliance. If we move on to the Kafka settings, we can do Kafka ACLs. We can do Kafka quotas if we want to. Again, you can do this via the UI. You can actually put it in version control as a YAML file. Everything in lenses you can do that with. So you could put this as a YAML file in version control, use the lenses CLI and actually apply your desired state. We have the quotas here. This is the configuration. To look at the configuration of lenses, it's not that interesting, I think. And this is the logs of lenses, just to show that it actually is APIs, right? I'm not lying to you, so you can actually automate everything around this. However, what I want to move on to is more on the data side, because MSK is providing that tech intensity for us. We don't want to get involved with actually installing Kafka itself. That's provided for us. We want to apply the data landscape on top and build that data intensity. So what we have here is a topology. So this is a live view of applications deployed on top of Kafka. We have already deployed some external applications. So these are some of the data generators we use, for example. But when we deploy these data generators, we actually have them register themselves with lenses. So here we have some microservices. So these could be Python, it could be Golang, they could be anything you want. They could be a Spark streaming job, they could be a Flink job, they could be a native Kafka Streams job, but they've registered themselves with lenses to say that they're there. If you use the Java SDK we have, you can also send us your internal topology as well via code. Otherwise, there's a REST endpoint to do it. You can also send us your metrics as well. These external applications all come into this list here. So we can see them here. We can remove them, for example, because it's deployed outside of Lenses control for the moment. In the future, we'll be adding this capability. We can remove it from lenses, or we can actually see it on the topology itself. And what's happening here is they're actually writing to 3 topics. So we can actually go and look at these topics as well. So if we drill into the topics by the explore screen here, we can see all the Kafka topics that we have here. We have an overview of size, records, key type, value type, and we do support JSON, Avro obviously, there's bytes here as well. We even support CSV and XML. And protobuf if you want to. If you want to add a topic, you can do it here again, but you can also do it via GitOps by describing everything as a YAML file and have the lenses CLI import everything for you. So we've got an overview of what's happening here in our Kafka system, but because we have connections, we can also see what's in Elasticsearch. So I've also got this index in Elasticsearch as well. But let's drill into this topic. There we go. It's returned us the data. So we can actually drill into the actual messages itself, both on the key and the value. If you want to, we can actually change the offset and query by offset. We can also do it via time as well. It's a bit more relevant, I think. So you can actually browse by time. But everything you're seeing here is actually powered by our SQL engine. So this is the snapshot version of the SQL engine that is running. So let's just have a look at how we do that. So this is actually running in this case, a live sample mode. So it's like tailing the end of a log, but the SQL still works the same thing. Let's narrow it down. I don't want the whole set of fields. I want speed. You get IntelliSense. So we'll say where speed is greater than 10 and run that query. Then we should just start seeing the new information come through. There it is. We're just getting speed and accuracy coming through here if we wanted to. We can also join and aggregate here as well. In fact, if you want to see me doing it on top of Redis, I am on YouTube doing a live aggregation on top of Redis streams as well. Another technology that you can get from AWS. I can view the schema. So this case, this is an Avro schema. So here we're getting a view of the definition of the types, for example, and descriptions of what each field represents. We can also see partitions. So there we go, we have a partition map, and that's quite handy in case somebody's actually skewing their data and we're not utilizing the full cluster, we're only reading and writing to one broker. Here we have information about the 3 partitions, who's the lead broker, total number of records distributed across each, the number of size of the partitions in bytes, and then the offsets that we have as well. We can also see the consumers. There is no consumers on this topic, but you would see them here if they were there. And we can also see the configuration as well, and we can change the configuration. So is there a default value and has it been overridden, for example in this case here, the retention in bytes. If you have the permission, you can insert records, you can delete records, we can change the key types. Lenses makes an attempt to figure out what it is, so the SQL engine can deserialize it, but maybe you need to change it for some reason. We can also edit the schema, and we could increase partitions, for example, if we wanted to. And we have a summary on the right hand side. But what's also quite interesting here is if I search, maybe I'm interested in credit card numbers, so I can actually search here as well. And that search would extend out to Elasticsearch, although there doesn't happen to be anything there at the moment. But what you get here is filtering and searching across all data sets. And this is actually, if I want to find out, show me everywhere that's credit card number in my system, we can see it here. So we can see we've got 3 topics here, and they potentially have something that has credit card number in it. If I just put an N in there, it should filter a bit more. Okay, CC payments and CC data as well. I think if I do provider, there we go, we're also searching across Elasticsearch. So this is part of the Lenses building up the data catalog functionality to build up that data intensity. But what's interesting is we have something else called data policies. So if we look at this data policy here, the credit card that we put in, basically we also say apply redaction. And what it's done is that it's got 3 fields in it, and it's identified 2 topics. We just saw that via the other Explore screen as well. But it's actually identified no connectors that are using it, or no processes, but it has identified 2 applications that are using it. So if we drill into it a bit further, we see what it has. It has 3 fields, credit card, credit underscore card, credit card, and CC number that have been entered. That what we're telling Lenses is a credit card number. It's identified 2 topics that have it. It would also identify any indexes in the Elasticsearch that had it as well. In terms of applications that are using it, so okay, this is my sensitive data, who's now using it? It's seen that we've got these 2 applications that we're using it, so that's the custom applications we looked at before. But if we actually drill into it, what you actually see here is that we've applied the redaction. So we actually have a number of customers in the financial industry that actually are able to expose Kafka data to third parties, because we have the role-based security model, and we have the auditing. You can even audit queries, so every time Lenses fires a query, it will be audited. And then we can apply redaction to actually obfuscate the data from any endpoint that Lenses exposes it to as well. So that's all great. So we can query Kafka. We can query it in a live stream mode as well. But what about actually querying Elasticsearch? So we can actually go show connections here. And in the SQL Studio, you actually see the 2 connections that we have. We have the default Kafka one and AWS. But we can also go use, I have to escape this, AWS EKS is the name of the connection I want to use, and then show me the index as, well, show me tables. And now I can see that we have an alert payments and a Kanban 1 index. So I should be able to go select star from alert payments, and let's limit it so we don't destroy the browser by pulling too much data back. And there we go, from Lenses, we're not only being able to query Kafka, but we're actually being able to query Elasticsearch, and we have other systems coming in as well. And you get the full power here of the IntelliSense as well. So it's the full-blown query engine. Okay, we have schema registry as well. So please put data in Avro. We can manage the schemas for you if you want to. But what I want to actually move on to is back to my topology. So great. I've got 3 applications generating data. Now I actually want to join this, right? So what I'm going to do is I'm going to deploy a SQL processor. So this is a Lenses SQL processor that we have, which does a continuous processing of data, and we're actually going to deploy this guy into Kubernetes. You can see this running in Kubernetes mode in here. So this is AWS EKS that Lenses have been configured to actually deploy SQL processors to do it. So I'll deploy a SQL processor. Just give me a second while I copy my pre-prepared SQL statement. So to create a new processor, pretty easy. Again, this is config. You can do this all in the YAML file and put it into your version control. Let's just demo processor. Let's call it that. I only want one runner, so I only want one pod or one instance of the application running in this case. Here's my SQL statement. It's pretty straightforward. We're setting some values up here that set the attributes onto the underlying Kafka producer and consumer. We actually have some credit card data, so this is the static data, effectively representing who's got credit card and who's not. This is the stream of transactions, and we're doing a join. And we're going to filter for where the credit card is blocked, and then we're going to write the data back. So we're actually doing a join and an aggregate as well. So what you're actually getting is the full power of Kafka streams here, what it boils down to when we deploy it, but it's defined by Lens' own SQL, and we're allowing you to deploy it directly into Kubernetes. You can either deploy it into Kafka Connect or run it inside Lenses as well for a development environment. Here we select the cluster, so this is our EKS cluster. We'll select the namespace, and we'll give it a pipeline. So this is what would get injected into the label of the Kubernetes pod. And we'll say the application ID, which is the consumer group, is also Andrew, and we'll create it. So now we've created it, but let's actually start it. So this is where we're going to deploy it. So it's off running to Kubernetes, and hopefully it should have started, and it has started. So this is a runner. This is the pod name, for example. If you wanted to, we could see the metrics. They will eventually come in. We could also see the logs. So this is the logs that we're actually getting from the runner there. You can see that's the SQL statement that's been injected into it. So actually, you remember, this really is config as code, and you can put that all in version control. So there we go. We have an application running that's joining, that's aggregating data. We can see what it's doing via the topology. It will come in here. There it is. So we can see that we have this more or less static reference data coming in along the top. We have the stream of real-time transactions. We're joining, we're aggregating, and we're writing them back. So he should now be on our topology. Yeah, there he is. So it's writing data out. So that data hopefully should be coming out into my target topic. Okay, there's our topic. He's turned up after we just created the processor, so we can actually go and drill into the data, and we can see that it's writing out here for this particular visa provider. There's been 1,747 attempts to use it. Right? It's not real data. It's fake data. But what it's showing you is the fact that we can actually deploy a SQL processor and actually deploy him into Kubernetes provided by AWS, join aggregate data, write it back to Kafka, and actually have it monitored via Lenses. What we can also do here is we can actually take this data out and we can write it out to a target system. So, for example, let's say we want to write this out to Elasticsearch, and that's also a service provided by AWS. What we can do is we can come into the connect page. Here we have the connectors that have been deployed in the Kafka Connect cluster, the plugins. This Elasticsearch one, I'll put in the configuration details here, but what's interesting to know, two things here, is we have a SQL statement here. And this is another SQL language that Lenses has. It's called Kafka Connect Query Language. So what we're actually saying is insert into this index attempted frauds, select star from frauds detection. From our topic, that's the output of the SQL processor. You can actually select fields in here if you want to as well, and each source and sync connector we have supports different grammar depending on what system they're connecting to. For example, we could set the suffix on the indexes here and set the document type if we wanted to. If we were writing to Redis, we can say whether we want what type of structure we wanted in, whether we wanted it in a multi-map or a cache, for example, or even Redis streams. We also have external secret support. So please use this if you're using Kafka Connect, because you don't want to leak passwords, and Kafka Connect will expose passwords via the APIs. But what this is a plugin for Kafka Connect. It has an external reference, and what this is saying is that we want to use the AWS plugin that's installed on the Kafka Connect cluster. You want to go to this secret manager and look up this key, because that's secret, and resolve that at runtime. So here's the secret manager, and this is what it is inside of AWS Secret Manager, and this is the value that we want to retrieve, and that will be resolved at runtime from the connector. So I can go ahead and deploy that. It's off, it's running. I can restart the task here if I want to. I can do all the actions of pausing the connector, restarting the whole connector, edit the config, etc. Everything that you can do via the API of Kafka Connect you can do here, but of course deploying connectors is all bound by the role-based security we have. So if you don't have permission, you're not going to be able to deploy it, and you're not going to be able to deploy a connector on a topic that you are not allowed to see or have permission to view. So there we go, we've deployed the connectors, and if we go back to the topology, we shall see the connectors actually being deployed here as well. So that's us writing off to Elasticsearch. We can also do another one. Let's say we want to write to S3, right? You know, we also have a connector. These are all open source connectors, by the way. You can find them in our GitHub repo at lenses, or go to lenses.io, and you can find them. Apache 2 license as well. So let's say we also want to take this C position report out, and we also want to write that out to S3. We can also do that. So if we go back in, new connector, in this case we choose the S3 connector. Here I'll post in the config I already have. So again, we're using our SQL engine here to say I want to insert into this bucket, into this container, flick positions, select everything from C positions. I want to store it as JSON. You can also store it as Parquet and Avro, and I want to flush every 5,000 records. We also are again using the secret manager that we have here as well to look up at runtime two different parts. So I'll create that connector. He's created. Yes, here he comes. Kafka API sometimes connects, sometimes a bit slow. He's been deployed. And if we go back to topology, there he is. So let me just go and check and see if we are getting data written out to Elasticsearch, not Elasticsearch, sorry, the S3 bucket. Let me just come over here, and this is our S3 bucket that we had before. There we've created the bucket. Nothing's come in yet, but in a few minutes it would come in. Oh, there we go. We've created partitions already. So then we will start writing into these Partitions, this lines up with the Kafka partitions on the topic that we created. And the sink will start automatically writing the data into that and flush it accordingly. When it gets the 5,000 records, we might have to wait a bit for that to come in. But there you go. So what you're getting is data intensity on top of MSK. We're deploying applications via SQL. We're deploying connectors to integrate with all the different services that Lenses and AWS provide. We're also giving you monitoring at the lower level of the infrastructure utilizing the open monitoring from AWS. We also can show here, for example, consumer lag. We can alert on the consumer lag. We can send that out to CloudWatch. We can set up alerting on data produced because you want to have data context around your streams. So this is moving the monitoring higher up the stack as well. And we also just give you information as well on the underlying infrastructure should you need it. But plus, of course, the visibility into your data assets, not just across Kafka, but also across Elasticsearch, because that all comes back to building your application landscape and the data intensity.